Hi, I'm Miss Hall, and this is Lesson 42, Exponential Growth and Decay Functions, Exponent of t. An exponential function has the form y equals ab to the x, where a is not 0 and the base b is a positive real number other than 1. If a is greater than 0 and b is greater than 1, then y equals ab to the x is an exponential growth function, and b is called the growth factor. The simplest type of exponential growth function has the form y equals b to the x power. Okay, so we're going to begin with exponential growth. So the function f of x equals b to the x power, where b is greater than 1, is the parent function for the family of exponential growth functions with base b. The graph shows the general shape of an exponential growth function. So you'll see that the graph is growing as you go right. The y-intercept of the parent function is when b is 0 and anything to the 0 power is 1. So that's why the point here is 0, 1. And the x-axis is the asymptote of the graph. An asymptote is a line that the graph approaches more and more closely, but never actually touches. It never touches the x-axis. Okay, and we can, compare this to the exponential decay function. Exponential decay is almost the same function, right? F of x equals b to the x. But now b is between 0 and 1. And this is the parent function for the family of exponential decay functions with a base of b. The graph shows the general shape of exponential decay functions. Maybe it makes sense from the name exponential decay. It's getting smaller and smaller. The y values are getting smaller and smaller. It has the same y-intercept, right? Anything to the 0 power is 1. So this is 0, 1. And now it has the same asymptote actually. The x-axis is an asymptote of the graph. As x gets bigger and bigger, the y values are approaching that 0, but they never hit it. And we could say for both of these, the domain for both exponential growth and exponential decay is all real numbers. And the range for both is y is greater than 0. Example 1, graphing exponential growth and decay functions. Tell whether each function represents exponential growth or exponential decay, then graph the function. To tell what is growth or decay, we look at that b value. Right, the form is y equals b to the x power. Here, b is equal to 2, which is greater than 1. And when b is greater than 1, we have exponential growth. So this is an example of exponential growth. If we want to write because b is greater than 1. Now to graph it, you could put this in a graphing calculator certainly. I am going to make a table of values. I'm going to go from -2 to +2. So I have 2 to the -2 power. Good thing last unit was how to deal with exponents. So this is really 1/4. 2 to the -1st power is really 1/2. 2 to the 0 power is 1. 2 to the 1st power is 2. 2 to the 2nd power is 4. So 1. This makes sense. The base is 2, so every time the y value doubles, 2 and then 4. Every time the y value doubles as the x's grow, and if you go backwards, the y value is cut in half. The x-axis is the asymptote, so the line gets closer and closer to the x-axis, but actually never touches. And I will just label this y. Now we'll do the same thing for the second exponential function, and now we have a b value of 1/2. So this is exponential decay. because b is between 0 and 1. X and y. And I'm going to go from the same values. So we have 1/2 to the negative 2 power. It's really 2 squared, which is 4. 1/2 to the negative first power is 2. 1/2 to the 0 is 1. Anything to the 0 power is 1. 1/2 to the first is 1/2. 1/2 to the second is 1/4. So we have negative 2, 1, 2, 3, 4. Negative 1, 2. Goes in half. Asymptote is still the x-axis, so we get closer and closer, but never touch. And now we have an example of exponential decay. Okay, exponential models. Some real-life quantities increase or decrease by a fixed % each year or some other time period. The amount y of such a quantity after t years can be modeled by one of these equations. Exponential growth or exponential decay. Exponential growth is y equals a times 1 plus r to the t. Decay is y equals a times 1 minus r to the t. Note that a is the initial amount and r is the % increase or decrease written as a decimal. The quantity 1 plus r is the growth factor and 1 minus r is the decay factor. Example 2. The value of a car y in thousands of dollars can be approximated by the model y equals, I'm going to write this larger, y equals 25 times 0.85 to the t power, where t is the number of years since the car was new. Tell whether the model represents exponential growth or exponential decay. So labeling different parts, this is my a value, and a is the initial amount. A is the initial amount. The initial amount of this car was $25,000. And now this second piece is either my growth or decay factor. It is either my growth or it's my decay factor. Okay. It's a growth factor if it is greater than 1 and a decay factor if it is less than 1. So 0.85 is less than 1, so this is a decay factor. Okay, so it's not a growth factor in this example. And this tells us we have exponential decay. Kind of like on the front when we were graphing, if that base is between 0 and 1, it's exponential decay. Now part B, identify the annual % increase or decrease in the value of the car. We've already talked about it's an annual decrease, and now we've got to figure out what is that value that is decreasing by. So we can say it is 1 minus some rate of decrease, and this equals 0.85. Therefore, maybe you want to move r and do 1 minus 0.85. R equals 0.5, which is a % written as a decimal. So this is really a 15% decrease in the value of the car. Eventually, you're going to start to see like 0.85 and say, well, I know that's less than 1, and that's 0.15 less than 1, so it's a 15% decrease. And you will not have to show this work, but you will have to come up with the R value. Is it growing or is it decreasing, and by what amount? The value of a car y in thousands of dollars can be approximated by the model y equals 31 times 0.92 to the t power, where t is the number of years since the car was new. A, tell whether the model represents exponential growth or decay. Because this base is less than 1, I know that it is exponential decay. I wanted to, because 0.92 is less than 1. Okay, part B, identify the annual % increase or decrease. It's a decrease in the value of the car. So 1 minus R equals 0.92. I can tell you right now that R is 0.08. I can solve that in my head, which is 8%. And so this is an annual decrease of 8%. So an 8% decrease annually.